Sometimes the trinomial you're about to factor has a factor common to all three terms. So before we start the process of finding the product and the sum and making a list of factors, we should always look to see if there's a common factor to all three terms. In this case, 2 goes into all three of these numbers. So I can undistribute a 2. And when I do, I get x squared plus 5x minus 14 left over, because 2 times x squared gives me 2x squared, 2 times 5x gives me 10x, and 2 times negative 14 is negative 28. Now that I've done that, I can factor this trinomial as I did in the part before. In the part before, I started by finding my product and my sum. In this case, my product is 1 times negative 14. My sum needs to be 5. So let's go make a list of ways to write negative 14 as a product of two numbers and see if we can figure out which pair of those gives me 5. Since I'm looking for a negative product, I can either write positive a small number times negative a large number, or negative a small number times positive a large number. Which one of these is going to give me a positive sum when I add them together? Well, it's going to be the one where the small number is negative and the larger number is positive. So as I make my list, I only need to worry about the small number being negative and the large number being positive. 3 doesn't work. 4 doesn't work. 5, 6, 7 works, but I've already got a 7 times something. This would be negative 7 times 2, but for two reasons I don't need this. One is I already have 2 times 7, and those are the same. And the other is that we said we wanted a small negative number and a large positive one. Here I have a large negative and a small positive. So that's not what I want. As it turns out, these are the only two ways that you can write negative 14 as a product of two numbers. And only one of them adds up to 5. So these are the two numbers I need to use to rewrite 5x as two terms instead of one. I'll write my first term, my last term, and then go back in and rewrite 5x as negative 2x plus 7x. And now I can continue as before. What's common to these two terms? X. What's left over? X minus 2. X times x is x squared. X times negative 2 is negative 2x. What's common to these two terms? 7. What's left over? X minus 2, because 7 times x is 7x, and 7 times negative 2 is negative 14. Copying down my GCF one more time, what's common to these two terms? It's x minus 2. And what's left over is x plus 7. From now on, the first step in factoring should always be to look for the greatest common factor of all of the terms. Sometimes that will still be 1, but sometimes it will not. And so it really pays to ask yourself every single time, if I'm factoring, the first thing I need to look for is the greatest common factor. What do negative 3, positive 3, and 18 all have in common? There are a couple of different ways you could answer that question. One is to say that it's 3, and that what's left over is negative 1, positive 1, and positive 6. Another way you could think of this, though, is that negative 3 is the common factor, and what's left over is positive 1, negative 1, and negative 6. We'll try and do it both ways. All I've done here is find and factor out the greatest common factor of the number part of each term. Now we need to go back and deal with the variable. What do x cubed, x squared, and x all have in common? There's one copy of x in each one of these terms. One term only has one copy, so that's the most that I can factor out. Rebuilding it, or undistributing, gives me 3x times what is negative 3x cubed? Well, I've already dealt with the number part. The 3 times negative 1 gives me negative 3. But x times x squared is what I need to get x cubed. Since I factored out a 3, I need to ask what I multiply 3 by to get 3, and that's 1. And then what do I multiply x by to get x squared? And that's x. And I'm getting a positive from multiplying a positive by a positive, so this is also positive. For my last term, positive 3 times positive 6 gave me positive 18, and x times 1 gives me x. So I could write times 1, but I don't really need to. It was a positive times a positive to get a positive. So this is also a positive. Looking at this the other way, if I factor out a negative 3, then I need to ask myself, negative 3 times what gives me negative 3? Positive 1. Negative 3 times what gives me positive 3? Negative times a negative is a positive, so this needs to be negative. A negative 3 times what gives me a positive 18? Again, since this is negative, I need this to be negative for that product to be positive. The variable part doesn't change. I have one copy of x in all three terms. Undistributing that one copy leaves only two copies here, leaves one copy here, and since I've undistributed that x, there are no copies left here. At this stage, this form of the answer looks like this. And this form looks like this. They're actually both correct. You can write them either way. Now we need to find our product and sum, make a list of products, and find the right sum. My product in this case is negative 1 times positive 6, and my sum is positive 1. 6 can either be negative 1 times positive 6 or positive 1 times negative 6, but I want my sum to be a positive number. So a negative small plus a positive large gives me a positive answer, but a positive small plus a negative large would give me a negative answer, and that's not going to work for me. Negative 1 times 6 is 6, 2 times 3 is 6, I want my smaller number to be negative. When I add these two together, I get 1. So this is the combination I need to rewrite the middle term. That means I can rewrite this problem now in this form. I'll rewrite the middle term as two terms, negative 2x and positive 3x. Then I'll look for what's common to the first two terms, and that would be negative. They're both negative, so I'm going to get a negative x, and what's left over is x plus 2. Negative x times x is negative x squared, and negative x times 2 is negative 2x. This sign comes down. What's common to these two terms? 3. What's left over? X plus 2. What's the common factor inside? It's x plus 2. What's left over? Negative x plus 3. Doing it this way, I have negative 3x outside and x squared minus 6, and I need to split up my middle term into two terms inside. I don't have much room left to do this. My product is 1 times negative 6, and my sum is negative 1. Negative 1 this time. Negative 1 times positive 6 is going to give me a positive answer. Whereas positive 1 times negative 6 will give me a negative 5. So in this case, I want my negative number to be the bigger of the two. The other way to write 6 as a product is 2 times 3, and I want the bigger of the two numbers to be negative. Adding these two together gives me negative 1, and that's what I'm looking for. So I'll rewrite this middle term as plus 2x minus 3x. Rewrite my greatest common factor, find the factor common to both of these terms, write what's left over, bring this down. What's common to 3 and 6 is 3, and what's left over is x plus 2, because a negative times a positive gives me a negative. What's common to both of these terms is x plus 2, and what's left over is x minus 3. I hope you followed all of that. I'm going to erase some of it now, but not all of it. I want to leave the two answers where we can take a look and see that they're both the same. Okay, I did this problem two different ways, and I came up with what looks like two slightly different answers. They're different looking, but they are equivalent. Let's take a look at the different pieces. Let's start by remembering that I can always write 1 times. That means I've got a factor of 3 in both answers. I also have a factor of x in both answers. I also have a factor of x plus 2 in both answers. What's different is that here I have a positive 1, and here I have a negative 1. And here I have a negative x plus 3, and here I have a positive x minus 3. So if anything's different, it's 1 times negative x plus 3 and negative 1 times positive x minus 3. But watch what happens when I distribute this 1 and this negative 1. 1 times negative x is negative x, plus 1 times 3 is 3. Negative 1 times x is negative x, and negative 1 times negative 3 is positive 3. These two things are equal. If 1 times negative x plus 3 equals negative 1 times x minus 3, then that times everything else is being the same, means that the whole product is the same. So although these two products look slightly different, they are in fact equivalent. This is a slightly more preferred form of the answer, because it's kind of messy to have that leading negative inside the parentheses. If we're going to have a negative, it kind of tidies things up a little bit to bring it out front like this. For now, I don't care which of the two answers you end up with. You won't lose any points for this form. The answer still has to be correct and equivalent to a correct answer, but just leaving the negative inside the parentheses or coming up with this as an answer isn't going to lose you any points. Okay, here's our last one for this part. X squared plus 8xy plus 12y squared. Remember that the first step is to factor out the greatest common factor of all three terms. So what number goes into 1, 8, and 12? Nothing, or at least 1. So I could write down 1 as my greatest common factor, and I would just have the original expression as what's left over. That's not wrong, but all it's done is introduce parentheses without changing anything else. I haven't benefited by that. What about the variables? How many x's do I have in common in all three terms? I have 2 here, 1 here, and none here. So I can't factor an x out as a greatest common factor to all three terms because this term doesn't have any. It's not common at all, not to all three. What about the y's? Well, there are no y's here. So, although the first step should always be to check for a greatest common factor, there won't always be one. I chose to do this problem for two reasons. One, it shows that you need to check for a GCF, even though sometimes you won't find one. The other reason is that this problem has two different variables in it, but we can still use factoring by grouping to factor this trinomial. And we do it the same way. Having checked for a greatest common factor and not found one, I'll go to the next step. Find the product and the sum. The product is 1 times 12, which is 12. The sum is 8. Everything here is positive this time, so I don't need to worry about signs in this case. A positive times a positive is a positive 12. My sum is positive. I'm going to have a positive times a positive and a positive plus a positive, so everything's going to be positive. So all I need to do is find all the ways to write 12 as a product of two numbers. Adding these up, I get 13, 8, and 7. And 8's the one I'm looking for. So this is the line I need. These are the numbers I'm going to use to break up my middle term. I'll rewrite the problem as x squared. You can leave the 1 there if you want, but it's not necessary. Plus 12y at the back, 12y squared. And then I'll rewrite the middle term as plus 2xy plus 6xy. What I have in the middle term is some xy's, whatever those are. So when I break it up, I'm going to break it up into some xy's and some more xy's, whatever those are. Whatever they are, they're different from x squareds and they're different from y squareds. So whatever your variable package is in the middle term, that's what you break it up into, some and some more of those things. Now it's ready to do factoring by grouping. Find the factors that are common to the first two terms and the last two terms. What's common to 1 and 2? Just 1. What's common to x squared and x? Just x. And what's common to, well, there are no y's here, so it's certainly not common to both of these terms. X is the greatest common factor of these first two terms. What's left over? X plus 2y. Double checking, x times x is x squared, and x times 2y is 2xy. Bring this sign down. What's common to 6xy and 12y squared? Well, 6 goes into both 6 and 12, and y goes into both y and y squared. X goes into x, but there's no x in this term, so it's not common, so I can't bring one out. Undistributing, I get this. 6y times x is 6xy, and 6y times 2y is 12y squared. The common factor to the two big terms is x plus 2y. And what's left over is x plus 6y. And you're done. You can check your answer by redistributing. X times x is x squared. X times 6y is 6xy. 2y times x is 2xy. And 6xy plus 2xy will add up to 8xy. Finally, 2y times 6y is 12y squared. So this is the correct factorization of this expression.